we're going to continue in section 13.2. Again, just a reminder, this is 13.2 from the book, 14.2 in your math lab. So be aware of that as you're continuing to do your math labs and prepare for your final exam and some of those things. Make sure you are on the right section here. So we left off in our last video talking about how to find perimeter. We talked about land measurement. We talked about area a little bit. And so we're going to continue and look at area of different shapes. So some of these you're going to know pretty easily. Some of these may be a little new to you, and hopefully that's not a huge problem. And we'll look at a few examples along the way as well. So one of the first figures we need to know how to find the area of is a rectangle. And the area formula is very simple. It is length times width. Okay, that is the way we find the area. So you take the length, which is one side length, and the width, which is the other side, the adjacent side length, and you multiply them together. And that should make some sense, because as you multiply, what you've done is essentially a grid type multiplication where you have 4 units across, you have 3 units tall, and so that 4 times 3 is where the area comes from. For a parallelogram, it's similar. We don't call it length times width, and instead we call it base times height. That's where the BH comes from. Now, we have happened to label these parts as B and H. You can see the B here, you see the H here. But really it's base times height. So in a parallelogram, you know that opposite sides are congruent. And so if you take one of your bases, the height is the perpendicular segment that goes up from that base through the opposite side. Okay, that's what the H is in this case. And that H could have been drawn out here somewhere. That would have been fine as long as it's perpendicular. And that tells us how tall this parallelogram is. And so when we multiply base times height, we get that area. Sometimes that's easy. For example, in a rectangle, your base would be this length, your height would be the width, and so it's still base times height. Just in a rectangle, we call it length times width. In a parallelogram, again, that height has to be that perpendicular segment that goes from one side through the opposite side. So from the base through the opposite side. The next one is the area of a triangle. And this one is 1/2 times base times height. And we kind of mentioned this in the previous video when we talked about area a little bit. We did just very briefly mention the triangle area of a triangle formula. The reason it's 1/2 base times height is because if you were to take this same triangle and reflect it along this line, this segment AB, then you would have, in the second figure, this new triangle. And it would be a parallelogram. Well, if a parallelogram is base times height, the triangle then is half of that, right? And so it's 1/2 times base times height. And so that's something we'll be able to calculate pretty easily on most triangles, and we'll see some examples of that in just a minute. So right on cue, let's find the area of this triangle. This parallelogram. So on the first one, remember our area is base times height. Now, in a parallelogram, this length can be your base or this length can be your base. It doesn't really matter. But the height is the perpendicular segment from that base. So in this case, this has to be our base, this length, right? But it's only from here to here. Okay? Now, what's that measure of that side? Well, it has to be 5 units because this side is 5 units, and we know that in a parallelogram, opposite sides are congruent. And so our base then is 5. The height, which you see here, has to be the 8. And so 5 times 8 gives us an area of 40 centimeters squared. Remember, we talk about area, we're squaring the unit, right? Because we're talking about how many literal squares or tiles, if you want to think about it from the flooring standpoint. How many tiles can we put into that? Well, they're all squares, right? So it's 40 centimeters squared. And you can see that there. Now, on the next one, we want to find the area of the triangle. And so again, that area formula is 1/2 base times height. And so it's 1/2. In this case, our base is 10. The height, again, is a perpendicular segment coming up from that through the opposite vertex. So through this point. And so we see that as 4 centimeters. And so our area, now if you have a hard time, if you see the fraction, the 1/2, you go, I can't do it. It's just half of whatever that total is. So 10 times 4 is 40. And so it's half of 40, which must be 20 centimeters squared. Oh, and I wrote it right where it popped up there. If you have questions about that, let me know. And now look at the next one. Again, our area formula for the triangle is 1/2 base times height. And so it's 1/2. Now notice this time our base has to be this side, this segment AB. And the reason is because our height is the perpendicular segment through that side. Well, if you were to extend this side, then it would go through that side. So our height is from a vertex perpendicular through the opposite side. And so this 4 is that height. This side, this AB, has to be our base. And so our base here is 2. The height is 4. And so again, 4 times 2 is 8, and it's half of that. So it's 4 centimeters squared. And again, there's our final answer. If you have any questions about finding the area, make sure you let me know. These are parallelograms and triangles. We've got other area formulas we're going to talk about and some other examples we'll look at. But if you have questions about these, make sure you let me know. All right, so the next area is the area of a kite. And the area of a kite can be found by relating it to the area of a rectangle. So the formula is 1/2 diagonal 1 times diagonal 2. So diagonal 1 is this length, horizontally through the middle. Diagonal 2 is this diagonal that's vertical. And the reason it's half of that is because if you were to take that part 2 and rotate it down here, then what you would see is that you would have this type of figure where you have a rectangle. And if you were to do the same thing, I guess it rotated up in my picture, but let me do that. All right, so let's say rotating it up instead of down. So if you take this one and rotate it up, then you would have this rectangle. And if you take section 3 and rotate it up here, then you would have, I'm sorry, there, then you would have this figure, this rectangle. And so what you see then is that we're really finding the area of triangles. And so half of that length, half of this length times this length, because, no, I'm sorry, half of this length, I'm off to this morning. Let me do that again. Alright, so here's our diagonal, right? And so we're not using the whole thing, you're only using part of it. And then here's the other part. And so you're not using the whole length of each of those diagonals. And so that's where the 1/2 comes from. Again, it relates back to the triangle and the area of that rectangle. And so this is our formula. This is what you need to know more than anything else. And we may use that a little bit in some other examples shortly. Our next area is the area of a trapezoid. This one we will use a little bit. It's more common. It's 1/2 times the height times the sum of the bases. So remember, in a trapezoid you have two bases, and you can see that here, base 1 and base 2. And so we're going to add those together, multiply it times the height, which again is the same perpendicular segment through the opposite side, and then times 1/2. And again, the reason, as you look at this diagram to the right here, you see that you have a triangle that you need to find the area of, and then you've also got this part, which is a rectangle, but we're not counting this. And so, again, not going to get into a proof of why that works the way it does, but excuse me. But that is our formula. It's 1/2 times the height times the sum of the two bases. So let's try that one. Let's try to use that. So again, at the top of the screen here, I'm going to put our area for trapezoid. So it's 1/2 times the height times base 1 plus base 2. And so we want to find, in our first example, the area. So we know it's 1/2 times, in this case, the height, which is 4, times the sum of the bases. Well, 12 plus 16 is 28. And so then we'll take half of 4, this part is 2, times 28. And 2 times 28 is 56. And it is centimeters squared. So there's our first area. Now look at the next one. The next one's got a little bit more to it, and you kind of have to think a little bit. Okay? So in this one, we know both of our bases. We don't know the height. Okay, so let's think about this for a second. If this triangle, let's start here. If this triangle has a 45-degree angle here at the bottom at vertex D, then this vertex up here also, or that angle also has to be 45 degrees, because if it's 180 degrees total in the triangle, you know that this angle at angle F is a 90-degree angle, because it combined with the other 90-degree have to be 180, have to be supplementary. And so the 90 plus 45 plus this other 45 up here would give us the 180. Now, why does that matter? Well, if the two base angles are the same, then it means that this side length and this side length have to be the same. Okay? Because it's an isosceles triangle. Well, the same thing then must be true over here and here. So if I have these two sides that are the same, these two, and I know that it's a parallelogram because of that, and I know that it has a right angle, then this must be a square. So, if it is a square, then, and again, we know that because we know these sides are congruent. Because let's say we don't know it's a square for a second. If we know that this length and this h and this length are all the same, well, if you were to take this section here and you were to take it out of this, that means that this part from here, and actually it's not a square, it's a rectangle, from here to here and from here to here has to be a total of 6 units, because this 8 minus the 2 that we had at the top. And so those two pieces that are now 6 units combined, well, half of that is 3. And so this piece must be 3 units, and this piece must be 3 units, which means that our h has to be 3 units. Okay, now we know that because of the isosceles triangle. We know that this length and this h are the same. And then we know that if we take out this unit of 2 down here, take this part out, because again, it is a rectangle for sure because we have the right angle. And so we know this has to be 2 at the bottom. Well, what that leaves is 3 units on each side. And so if that's the case, then in our formula, our area is 1/2 times the height of 3 times the sum of our bases, which is 2 plus 8. And so as we simplify that, it's 1/2 times 3 times 10. 10 times 3 is 30. Half of that is 15 centimeters squared. So this figure in the middle, it looks like it is a square. This piece here in the middle, it looks like it's a square. It is actually not. Okay, so one of the things that, as I was kind of working through this initially, I said, well, it looks like it's a square. But you never want to go by the way it looks, because a lot of times these drawings are not done to scale. This bottom base probably is not 4 times as big as this top base, even though it should be if it's 2 and 8. And so we can't go by the way it looks. And it's easy to kind of get caught up in that and think, oh, well, yeah, that's a square. But we know it's a rectangle. We know it's a rectangle because we know that we have an isosceles triangle, which means that the two h lengths have to be the same, which both of them being h tells us that. And so we don't know that those are the same as the 2. Obviously, they're not in this case. So you can't assume that they're going to be the same. You have to actually figure out what is that length. And so I know there's a lot of stuff here, so I'm going to erase some of this off this trapezoid just to kind of clarify what all happened. Just I think with so much stuff happening here, it can be sort of confusing. So let me just kind of go back through that real quick and try to simplify it a little bit. All right, we knew that this side and this side had to be the same because we had an isosceles triangle. Okay, this triangle here to the right is an isosceles triangle. We know that because of the base angles. This angle is 45 degrees. This one down here that's shown is 45 degrees also. Same thing is true on this other side. This segment AE and that length of H have to be the same length. And if I take, because I know this is a parallelogram and a rectangle here in the middle, if I take this measure of 2 out down here, well, 8 minus 2 is going to be 6, right? So this section and this section together had to be 6 units. So since they're going to be the same, they have to each be 3 units. Again, we know they're the same. We've got that marked here. And so that's where that 3 comes in for the height. Because if this unit is 3, this is also 3. Okay? So I had a lot of stuff drawn there. I hope maybe that sort of helps that make some sense. And once you figure out the height, then obviously just put that into the to the formula, and you're able to find your area is 15 centimeters squared. That could be very confusing, so if you have questions about that one, please let me know, and I'll try to go back over anything that maybe I said that was sort of confusing. Alright, so let's talk about area of a regular polygon. So the area of a regular polygon can be found by 1/2 times A, which in this case is the radius, or if it's a circle, it would be the radius. It's the height of this triangle. Okay, so think about this. Find the area. We're really finding the area of a bunch of triangles. Right? That's all we're really doing as we find this area. So we need to find the area of one triangle. And so it's 1/2 that area. And then you'll notice it says times NS. That NS is the number of sides. Okay, so if this is a 15-gon, for example, then it would be 15 sides times the length of side S, which is also the perimeter. And that's why over here we have 1/2 AP, P being the perimeter. Okay? And so what that's going to give us is it's going to give us this area of this one triangle, and then it's going to be done however many times based on the number of sides in the triangle. And so all the way around it, we'll use that to find that area. And again, it's 1/2 times A. If it's a regular polygon, that A is the same length in every one of those triangles. And so 1/2 times A, and that's our height in the triangle, times the side length. And then we just do it however many times we have for the number of sides. And then we can kind of use that same idea to find the area of a circle. And so for a circle, again, if you were to think about this as a lot of little bitty triangles, so you could think about, well, if I were to split this into a smaller triangle here, and a smaller one here, and I could continue to split those into smaller triangles, the goal would be to try to get them to where it makes a smooth curve. And you can see that on this outer edge going around, we have a circle. What's in blue is a circle, and then you have the triangle that is actually here. So there's a little space missing that we need to take into account. And so you can't get your triangles to be small enough to make that work. And so how do we find the area of the circle? Well, it is simply taking pi r squared. Okay, so taking pi, which we've talked about as the ratio that we use in circles a good bit, times the radius squared. Okay, that is our area formula. Again, not going to get into a ton of detail about how we get that, when we get that, proofs or anything. That is our formula. Okay, area of a circle is pi r squared. And so then that leads us to the area of a sector. So a sector is a section of a circle. Okay. And so we can find the area by taking theta divided by 360. which is going to tell us the amount of rotation and take into account that area, times the area of a circle, pi r squared. Okay, and so if we know this theta, this angle measurement, then, and we know the radius, then we're probably going to be able to find the area of that section, of that piece of the pie or pizza, or however you want to think about that circle shape. Now that does take us to the end of section 13.2. We'll stop the video here. Our next video gets into section 3, and we start dealing with triangles a little bit more, and we talk about Pythagorean theorem, some, and some of those things. You will see problems throughout your math lab dealing with area. And so what I would encourage you to do is to have all of these formulas written out. Again, each slide pretty much has had an area formula. We've looked at a few examples, but you'll practice this on your math lab. Okay, so make sure you know those area formulas, put those all together somewhere, and that way you can use those as you need them, and then you'll practice these on the math lab. If you have any questions about any of these, make sure you